Welcome to Mason's Amazing Math. Hi, my name is Joseph Mason. I am a professor of mathematics at Hagerstown Community College, Hagerstown, Maryland. I have been teaching math for the past 43 years. I have seen many changes in math education over the years. Unfortunately, math education is probably at an all-time low due to the fact that most of today's computational math education revolves around memorizing facts, memorizing algorithms, using a one-dimensional approach, plugging numbers in, chugging to an answer, and showing all work. I would like to introduce you to a book I wrote to change the face of math education and get you excited about math. This book is full of different computational strategies that you probably never have been introduced to in your math education, but will make your experience with math much more enjoyable. I will now go through 4 of the many strategies included in the book that will intrigue you, amaze you, challenge you, allow you to view math from a different side, and change your perspective on math. First, have you ever taken a good look at the multiples of 9? What would you say if the need to memorize the multiplication facts of 9 could be replaced with one single concept? Well, take a look at the multiples of 9 carefully. Do you notice anything about the multiples of 9? Well, first, did you notice that the sum of the digits in each is equal to 9? Second, did you notice that the tens digit is 1 less than the multiplier? How can we use this conceptual understanding for our multiplication facts of 9? Well, an example, take 6 times 9. If you want the concept, first, tens digit is 1 less than 6 or 5. Second, since 5 plus 4 is 9, 1's digit is 4. Hence, 6 times 9 is 54. Look at another example, 3 times 9. First, tens digit is 1 less than 3 or 2. Since 2 plus 7 is 9, 1's digit is 7. Hence, 3 times 9 is 27. Right, if you're watching this video, you probably have your multiplication facts of 9 memorized and don't realize the power of this concept to someone just learning their facts. To let you understand the power of this concept better, let's look at a parallel numeration system, base 8, and learn the multiples of 7. 9 is the largest digit in base 10, 7 is the largest digit in base 8. Hence, the idea behind this concept may be applied to finding the multiples of 7 in base 8, similar to what we did for 9 in base 10. Can you use this conceptual idea to list the multiples of 7 in base 8? Press pause, try to answer, then press play to see the results. Okay, 1 times anything is that number, so 1 times 7 is 7. 2 times 7, 1 less than 2 is 1. 1 plus 6 is 7, so 2 times 7 is 1 6 base 8. 3 times 7 base 8, 1 less than 3 is 2. 2 plus 5 is 7, so 2 5 base 8 is your answer. 4 times 7, 1 less than 4 is 3. 3 plus 4 is 7, so your answer is 3 4 base 8. 5 times 7 in base 8, 1 less is 4, plus 3 is 7, so 4 3 base 8. And multiply by 6, you get 1 less is 5, plus 2 base 8. Now you know your multiplication facts of 7 in base 8. Did you have to memorize them? No. You just had to use the concept. All right, if we think about it, what would you say if I told you that the need to memorize the hardest 36 addition facts, sums that are greater than 10, could be replaced by one simple concept? What would you say if I told you that the need to memorize the hardest 45 subtraction facts, subtracting from a number greater than or equal to 10, could be replaced by one simple concept, just like we did for the multiples of 9? The book will show you this. Okay, second, let's look at a strategy for multiplying numbers involving zeros. If you take 2,134 times 20,010, The thought process would be, first, place the number with the least number of non-zero digits on the bottom. So we take 20,010 times 2,134. This looks a little funny to you because you were not taught to do this in this traditional method. You were taught to put the smaller number on the bottom. Second, multiply by the zero. Here we're going to remember, 0 times anything is 0, and you only need one 0 in the answer directly below this 0 in the answer. So 0 times anything is 0, bring one 0 down to the answer. Next, multiply by the 1. Start your answer directly below the 1 in the answer. So right below the 1, we multiply, we get 2,134, starting below the 1. Next, multiply by the next 0. Again, 0 times anything is 0, only need one 0 in the answer. So we bring straight down 0. Multiply by the next 0. Again, 0 times anything is 0, one 0 straight down in the answer. Multiply by the 2, start your answer directly below the 2. And finally, we add to get your answer. Okay, so this becomes 42,701,340. Now, if you would have done this traditionally on the left there, this is what you would have had. We just did it non-traditional on the right. What do you think? Which method would you prefer to use? Okay, time to try it yourself. Okay, press pause, work this problem out, and then press play to check how you did. Okay, so first you put 3,004 on the bottom, 2,132 on top. Multiply by the 4, start right below the 4. Multiply by 0, 0 times anything is 0, one 0 in the answer. Multiply by 0, 0 times anything is 0, one 0 in the answer. Multiply by the 3, start straight under it. Now we add to get your answer, and you end up with 6,404,528. Now, if you would have done this traditional, there on your left, you would have had rows of zeros. On the right is what we end up with, using non-traditional strategy. So which would you prefer? All right, third, you want to impress your friends? Learn to multiply numbers mentally without writing all the steps. Let's take a two-digit number times a two-digit number. For example, 35 times 42. We're talking two-digit times two-digit, so this implies hundreds is the largest value in your answer, because tens times tens equals hundreds. So first, step 1, compute the ones digit of the answer. So we have to take ones times ones. So we take 5 times the 2, which is 10. Write the 0 in the answer, regroup the 1. Step 2, compute the tens digit of the answer. Well, if you think about place value, the only way you're going to get tens is ones times tens or tens times ones. So you take the 5 times 4 is 20. 3 times 2 is 6. 20 plus 6 is 26. Plus the regroup of 1, you get 27. So you write the 7 in the answer, regroup the 2 to the hundreds place. Step 3, compute hundreds digit of the answer. The only way to get hundreds is tens times tens. So we take the tens times tens, takes 3 times 4 is 12, plus the regroup of 2, you get 14. So you just write 14 in your answer since hundreds was the largest value in the answer. So your answer is 1,472. So you come up with the answer without the steps in between. Try it yourself on the following problem. Press pause, work it out, come back to see results. All right, we take 6 times 3, which is 18. So we write the 8 in the answer, regroup the 1. Now we want to do our tens. So we take 6 times 5, 3 times 3. So we have 30 plus 9 is 39, plus the regroup makes it 40. Write 0 in the answer, regroup the 4. Now we want to come up with hundreds. 3 times 5 is 15, plus the regroup of 4, you get 19. So our answer is 1,908. Were you able to do that answer? Okay, so next, let's look at 3-digit number times a 3-digit number. So again, 3 digits times 3 digits implies 10 thousandths is the largest value in the answer this time, because hundreds times hundreds is 10 thousandths. So we start off the same way. Step 1, compute the ones digit of the answer. Ones times ones. 3 times 4 is 12. Write the 2, regroup the 1. Step 2, compute the tens, just like we did before. Ones times tens, tens times ones. So 3 times 3 is 9, plus 4 times 4 is 16, is 25, plus the 1 is 26. Write the 6, regroup the 2. Now step 3, we want to compute the hundreds. Now this time we have an extra column, so we have to take tens times tens for hundreds, but we can also take ones times hundreds and hundreds times ones. So 4 times 3 is 12, plus 3 times 1 makes 15, plus 2 times 4 is 8, makes 23, plus the 2 regroup, you get 25. Write the 5, regroup the 2. Step 4, now we want to compute the thousands. The only way to get thousands is tens times hundreds, hundreds times tens. So you take 4 times 1 is 4, plus 2 times 3 makes 10, plus the 2 makes 12. Write the 2 in the thousands, regroup the 1. Step 5, compute the 10 thousandths digits. The only way to get 10 thousandths is hundreds times hundreds. So we take 2 times the 1 is 2, plus the regroup makes 3. Okay, so our answer is 32,562. Do you think you'll be able to do this yourself? Let's try. Try it yourself on the following problem. Press pause, and when you're finished, come back and check your answer. First, ones. 1 times 3 is 3. Second, tens. 1 times 1 plus 3 times 3, so that's 1 and 9 makes 10. 0, regroup 1. Next, we want hundreds. We're going to take tens times tens, 1 times hundreds, hundreds times ones. So 3 times 1 is 3, plus 1 times 2 makes 5, plus 2 times 3 makes 11, plus the 1 makes 12. So we write the 2, regroup the 1. Next, we want to do thousands. Thousands is tens times hundreds, or hundreds times tens. 3 times 2 is 6, plus 2 times 1 makes 8, plus the 1 makes 9. Okay. Last, we want to compute the 10 thousands, which is 2 times 2, which is 4. So our answer is 49,203. Were you successful? What do you think? Will you be able to do this? All right, fourth, let's take the fear out of fractions. Non-traditional mental strategy for adding mixed fractions. If we had 5 3/8 plus 7 2/5. First, add the whole numbers of the problem to get the whole number of the answer. So 5 plus 7 is 12. Second, mentally multiply the diagonals of the fractions and add to get numerator of the answer. So we take 5 times 3 is 15, plus 8 times 2, which is 16. 15 plus 16 is 31. Third, mentally multiply denominators, get denominator of the answer. So we take 8 times 5 is 40. So 40 is the denominator of the answer. And last, check to see if your answer may be simplified. In this case, 31/40 will not simplify. All right, try it yourself on the following problem. Press pause, work it out, come back to check your answer. 4 plus 9 is 13. 7 times 2 is 14, plus 9 times 1 is 9. 23 is the numerator of the answer. 9 times 7 is 63, so 63 is the denominator of the answer. If we look at this answer will not simplify. Remember, the part in blue may be written out or performed mentally. Try it again on this problem. Press pause, try to work it out, and then come back to check yourself. 24 plus 15 is 39. 4 times 5 is 20, plus 8 times 3 is 24, gives you 44. 8 times 4 is 32, so we end up with 39, 44, 30 seconds. In this case, the answer will simplify. First, we could simplify 44 30 seconds by dividing both by 4, and we get 39 11/8. Now, 11/8 is an improper fraction, so we would regroup. So we get 40 and 3/8. We could have also regrouped right away. Take 32 into 44 one time, 12 left. So now we have 40, 12, 30 seconds. Then we could have simplified to 12 30 seconds by 4. Get 4 3/8. Same answer either way. What do you think? Make life a lot easier with fractions because you don't need to find a common denominator and rewrite? What is the name of the book that is filled with traditional, non-traditional strategies? It's called Changing the Face of Math Education, Book 1. It's 442 pages. What is included in the book? First, detailed explanations of many different traditional and non-traditional computational strategies. Second, detailed examples for the different computational strategies. And third, many different problems to practice the different strategies with detailed answers given in the back of the book. Who is the book for? Teachers, students, parents, anyone who wishes to be amazed, intrigued, and challenged when it comes to math. Your speed and accuracy are bound to greatly improve by implementing the different strategies discussed in this book. Where can you get the book? Option 1. If you want to order a printed paperback copy in full color, it's $49.99, but right now it's on sale at 20% off. Go to www.lulu.com/shop and enter the title, Changing the Face of Math Education, into the search box. Option 2, if you want to download a PDF copy today, $24, or a PDF copy of a particular chapter, $3. Go to www.teacherspayteachers.com and begin entering Mason's Amazing Math into the search box until it appears. Then click on it. I would like to thank you for taking the time to view this video. Hopefully this video intrigued you, challenged your mind, excited you about math, and changed your view of math. I would appreciate it if you share this video and/or the information discussed in the video with your friends. I would also like to invite you to visit my Facebook page, Mason's Amazing Math, to register a like and/or post a comment. Once again, thank you, and the websites are listed below.